in this schematic, the raw water pump. Here is located the raw water pump. This is the raw water pump, and here is located the seacock valve. No, that's the valve, and the raw water enter in the bottom. Okay, and this is the raw water pump. And the raw water pump circulates the water, and the water goes out into the risers, into the manifolds of the exhaust, and goes outside with the smoke at the same time with the raw water. And internally, normally the majority of the engines, they use the circulating pump or coolant pump located in the center of the block. That circulating pump, in this particular case, circulates salt water, no coolant. In this particular case, the engine have two pumps, one raw water pump external and other pump bolted on the block of the engine, the fresh water or circulating pump. In this particular case, work with salt water. I have another better picture here, exactly that, but this is the inconvenient. Those cavities dedicated for the flow of raw water are completely clogged. If you don't use the engine continuously, if you use the engine each 2 weeks, once per month, the salt water close those cavities, and at the end of the day you have a lot of problems. Those are the gases in the middle, and the blue one is the flow of water, and here is located the hose. This is the hose, and those are the hose clamps. Those are the hose clamps, and this is the situation. The raw water pass on the blue pad, and the red one is the exhaust gases. This is the riser here. This is the riser, and from the bottom is the exhaust manifold. Right? This is the typical situation. I have an example of how the water circulates in this particular engine. If you see in this video, the raw water passed from the side, and now you can see the raw water here in this on the side, and other one here. Yeah, of course, the hose is located in the external ring. Here is located the hose to connect water with gases together. The raw water pump is composed. Normally, the raw water pump is connected with the belt, and is connected with the crankshaft of the engine, with the pulley of the crankshaft. Immediately, you have access to the pump. The first step is check if the pulley is in good condition. If the pulley is no crack, no dent. And the next step is verify if the pulley doesn't have play. If the pulley have play, is because the shaft is broken. If the shaft is broken, normally is because the raw water pump is leaking constantly. This is an indication that the shaft is broken, or the seals internally are broken. This is the tool. We are going to try to use right now the tool. We are going to close both ends. We are going to close both ends properly. And now we are going to apply pressure in the middle in order to remove carefully the impeller. And right now we have the impeller. The impeller is ready to be replaced. As soon as you start the engine, you verify that you don't have leaks in the bottom of the pump, that the pump is running properly. If you have a small leak, the recommendation is stop the engine and try to tighten the bolts a little more. If the leak continue, I recommend remove the plate, clean the plate again, putting back the gasket with the grease in both sides, no silicone. Never use silicone, because the silicone is not good. The silicone, the impeller suction the silicone and transport the silicone at the input of the heat exchanger and clog the heat exchanger. This gasket is very important. You need to keep this gasket in good condition. You can order the kit in order to repair the strainer. The strainer is composed for the gasket, the basket. This is metallic in stainless steel, and the kit is coming with the two O-rings, one O-ring on top, other O-ring on the bottom, and with the crystal. In some cases, if you need to replace the crystal for a new one, it's coming. The idea is keep this strainer in perfect condition, completely clean.